Students, today we will discuss some more problems on continuity. The first question, prove that f of x is equal to mod cos x. Prove that f of x is equal to mod cos x is a continuous function. Okay, so prove that f of x is equal to mod cos x is a continuous function. Okay, so now I will take let g of x is equal to mod x and h of x is equal to cos x. Okay, let g of x is equal to mod x and h of x is equal to cos x. Okay. Now mod x is a very well known function. Already we have seen that this is continuous throughout its domain. Mod x, the domain of mod x is the set of all real numbers. So mod x is a continuous function. Then cos x, it's a trigonometric function. And we know that every trigonometric function is continuous in their respective domains. So for cos x, the domain is the set of all real numbers, and therefore in that set of all real numbers, cos x is continuous. So we can say that cos x is a continuous function. Mod x is continuous, cos x is also continuous. G of x is continuous, h of x is also continuous. Now let us find out what is g circle h of x. G circle h of x, in other words, g composition h of x. G composition h of x is equal to g of h of x. G of h of x, that's equal to g of h of x. In place of h of x, I am substituting cos x. Okay, g of cos x. Look here, we have defined g of x as mod x. G of x is equal to modulus of x. Now we want g of cos x. So wherever there is x, we will replace that x with the cos x. G of x equal to mod x. Therefore, g of cos x will be equal to modulus of cos x. Modulus of cos x. Okay, so we have seen that g circle h of x is equal to mod cos x. That mod cos x is nothing but f of x. Therefore, I can write f of x is equal to g circle h of x. In other words, g composition h of x. G is continuous, h is continuous. Therefore, g circle h is also a continuous function. So we can say f of x is equal to mod cos x is a continuous function. Okay, after this you will write one sentence here. Since g is continuous and h is continuous, g circle h, in other words, f of x is also continuous. Okay, let us look at the next question. Show that sin mod x is a continuous function. Show that sin mod x sin mod x is a continuous function. Sin mod x is a continuous function. Okay, so I will treat this as f of x. Let f of x is equal to sin mod x. Then I will take g of x is equal to let g of x is equal to sin x and h of x is equal to modulus of x. G of x is equal to sin x and h of x is equal to mod x. Now I will find out g circle h of x. G circle h of x is equal to g of h of x. That's equal to g of h of x. In place of h of x, I will replace that h of x with mod x. G of mod x we want. G of x is defined as sin x So g of mod x will be equal to sin mod x. Wherever there is x, you have to replace that x with mod x. So that will give you sin mod x. G of x equal to sin x, therefore g of mod x is equal to sin mod x. Again, we know one theorem, that is, if f is continuous and g is continuous, then f circle g is continuous. Now in this case, g is continuous and h is continuous. Therefore, g circle h is a continuous function. So sin x is a continuous function, mod x is a continuous function. Therefore, sin mod x, being the composition of these two functions, is also a continuous function. Okay. So some of you may be getting this doubt. Yes, in fact, one student had asked that question in the WhatsApp group. That is, sir, how do you take this as g of x? How do we get to know that we have to take sin x as g of x and mod x as h of x? Okay, so for that I will clarify now. Look here, the given function is sin mod x. Sin mod x, there are two functions here. This is a composition of two functions. So it is very clear that one of them is sin x and the other one is mod x. Okay, therefore I take g of x as sin x and h of x as mod x. But if you reverse it, then what happens? If you reverse it, that is, see, as we identify that there are two functions, you take one of them as g of x, other one as h of x. Suppose if I take g of x is equal to mod x and h of x is equal to sin x, then what happens is, you try to find out what is g circle h of x. G circle h of x is equal to g of h of x, which is equal to g of sin x. That's equal to g of sin x will be equal to mod sin x. Okay, but we are given sin mod x, not mod sin x. So after getting g circle h of x, you will realize that this is not what we want. So in that case, what you do is, first is rub this. After that, instead of g circle h of x, you find out h circle g of x. H circle g of x, that is equal to h of g of x. That's equal to h of g of x. G of x is mod x. H of mod x. H of x is sin x. So h of mod x is sin x. Therefore h of mod x will be equal to sin mod x. So even if you reverse it, no problem. You take this as g and that as h. Then you have to find out h circle g of x. Okay? But even if you find out g circle h of x, at the end you will realize that you have gone wrong and then come back to this. Okay? So now you can say, since h is continuous and g is continuous, h circle g is also a continuous function. Okay. Let's go to the next question. The next question is, if f of x is equal to 4 when x is less than or equal to minus 1, ax square plus b when x is greater than minus 1 but less than 0, and it is cos x when x is greater than or equal to 0, is continuous at x equal to minus 1 and x equal to 0. Is continuous at x equal to minus 1 and x equal to 0. Find a and b. This is a function that I have given f of x, and it is mentioned that this function is continuous at x equal to minus 1 and continuous at x equal to 0. Then what are the values of a and b? That is what we have to find out. Okay. So already we have solved a couple of problems of this kind already in our previous video. So first we will consider the continuity at x equal to minus 1. Here in the question itself they have given that the function is continuous at this point. So since the function is continuous at x equal to minus 1, I can write that limit extends to minus 1 minus f of x. That is the left hand limit, which means x is approaching minus 1 from left side. that's equal to limit x tends to minus 1 plus f of x. X is approaching minus 1 from right side, that is equal to f of minus 1. Left hand limit is equal to right hand limit is equal to the functional value. Left hand limit x tends to minus 1. X is approaching minus 1 from left side. When x approaches minus 1 from left side, x is less than minus 1. There the function is defined as 4. That's equal to limit x tends to minus 1 plus f of x, which means x is approaching minus 1 from right side. When x is approaching minus 1 from right side, f of x is defined as ax square plus, that's equal to f of minus 1. At x equal minus 1, the function is defined as 4. So when I apply the limit as x tends to minus 1, 4 will remain as 4 only. And here, if I apply the limit as minus 1, put x equal minus 1, we get minus 1 whole square, which is 1 into a is a plus b is equal to 4, which I already written here. Treat this as equation 1. Okay. Now, it is also given that the function is continuous at x equal to 0. The function is continuous at x equal minus 1 as well as at x equal to 0. So now I will consider the continuity at x equal to 0. At x equal to 0, left hand limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x is equal to f of 0. Left hand limit is equal to right hand limit is equal to the functional value. Left hand limit, x is approaching 0 from left side. When x approaches 0 from left side, x is less than 0, then the function is defined as ax square plus b. That's equal to limit x tends to 0 plus f of x. X is approaching 0 from right side. X is approaching 0 from right side means x should be greater than 0. Whenever x is greater than 0, function is defined as cos x. That's equal to f of 0. At the 0, the function is defined as cos x. Put x equal to 0, we get cos 0. Cos 0, which is equal to 1. Apply the limit here. As x tends to 0, this will become 0 plus b, which is b. As x tends to 0, cos 0, we get 1. That is also 1. b is equal to 1. If I substitute here, we will get a is equal to 3 because a plus b must be equal to 4. Okay. Let's go to the next question. If f of x is equal to 1, if x is less than or equal to 3, ax plus b, if x is greater than 3 but less than 5, and 7 if x is greater than or equal to 5, is continuous at x equal to 3 and x is equal to 5, find a and b. Okay, so very similar to the previous question. If f of x, which is defined in this way, is continuous at x equal to 3 and at x equal to 5, then what are the values of a and b? So, first I will consider at x equal to 3. At x equal to 3, the left hand limit is limit x tends to 3 minus, since it is continuous at x equal to 3, I can write left hand limit is equal to right hand limit is equal to the functional value. Left hand limit is equal to the right hand limit is equal to the functional value. So left hand limit, x is approaching 3 from left side. When x approaches 3 from left side, the function is defined as 1. Then when x approaches 3 from right side, the function is defined as ax plus b. And at 3, f of 3, when I put x is equal to 3, at x equal to 3, the function is defined as 1. Okay, here it is 1. Apply the limit, we get 3a plus b, that's equal to 1. Already we have treat this as equation 1. Now, it is mentioned that the function is continuous at x equal to 5 also. So, at x equal to 5, limit, left hand limit x tends to 5 minus f of x is equal to limit x tends to 5 plus f of x is equal to f of 5. Left hand limit is equal to right hand limit is equal to the functional value. Okay, so limit x tends to 5 minus x is approaching 5 from left side. When x approaches 5 from left side, the function is defined as ax plus b. Then limit x tends to 5 plus f of x. X is approaching 5 from right side. When x approaches 5 from right side, x is greater than 5. When the x is greater than 5, the function is defined as 7. Then the functional value f of 5 at x equal to 5, the function is defined as 7. Here apply the limit, we get 5a plus b is equal to 7. Here we have 3a plus b equal to 1. Here we have 5a plus b is equal to 7. I write this as equation 2. Now I go for equation 2 minus equation 1. So let us subtract this. Equation 2 minus equation 1. I do 5a minus 3a, that will give you 2a. B minus b, that b gets cancelled. On RHS we have 7 minus 1, which is equal to 6. 2a is equal to 6. Therefore a is equal to 3. When a is equal to 3, substitute here. In the first equation I will substitute 3a plus b is equal to 1. That will give you 9 plus b. 9 plus b equal to 1. So b is equal to minus 8. A is equal to 3, b is equal to minus 8. Okay. Let's go to the next question. If f of x is equal to, if f of x is equal to 2x square minus 3x minus 2 divided by x square minus 4 whenever x not equal to 2 and k when x is equal to 2 is continuous at x equal to 2. Is continuous at x equal to 2. Is continuous at x equal to 2. Find k. Well, say in this question they have given that this function is continuous at x equal to 2. Then what is the value of k? That's question. The function defined as f of x equal to 2x square minus 3x minus 2 divided by x square minus 4 whenever x not equal to 2, and when x is equal to 2, the function is defined as k. Then this function is continuous at x equal to 2. What is the value of k? That is what they are asking. Okay. Since f is continuous at x equal to 2, we can write limit x tends to 2 f of x is equal to f of 2. Limit x tends to 2 f of x is equal to f of 2. Now, limit x tends to 2 f of x. In place of f of x, I will substitute it. 2x square minus 3x minus 2 divided by x square minus 4. That is equal to f of 2. At x equal to 2, the function is defined as k. Okay. So the limiting value of this will be equal to k. Okay. So if I directly apply the limit, let us see what happens. Here we get 2 into 2 square. 2 square is 4, 4 into 2 is 8. Minus 3 into 2, 6 minus 2. So you have 8 minus 6 minus 2, which will be 0. And in the denominator, 2 square, which is 4, 4 minus 4, that will also be 0. So this is an indeterminate form. We will get 0 by 0, an indeterminate form. So what do? We should factorize this. 2x square, you can directly write, or if you want, I will factorize. 2x square minus 3x minus 2. When we multiply, we should get minus 4x square, and when we add, we should get minus 3x. So we get 2x square minus 4x plus x minus 2. So 2x into x minus 2 plus 1 into x minus 2. We can write this as 2x plus 1 into x minus 2. Okay. So this will be a limit x tends to 2. After factorizing this, I am writing it as 2x plus 1 into x minus 2. Denominator x square minus 4. This 4 I am writing it as 2 square. Then x square minus 2 square is x minus 2 into x plus 2. This is equal to k. So now this x minus 2 gets cancelled. We have limit x tends to 2x plus 1 divided by x plus 2 equal to k. See here, I have cancelled this x minus 2. So we are left with 2x plus 1 and x plus 2. Apply the limit as x tends to 2. We get 2 into 2, that is 4 plus 1, 5 divided by 2 plus 2, 4 equal to k. So k is equal to 5 by 4. Okay, let's look at the next question. If f of x is equal to 1 minus tan x divided by pi by 4 minus x. 1 minus tan x divided by pi by 4 minus x when x not equal to pi by 4 and k when x is equal to pi by 4 is continuous at x equal to pi by 4. Is continuous at x equal to pi by 4. Find k. Find k. Right. Very similar to the previous question. If f of x is continuous at x equal to pi by 4, then what is the value of k? That's the question. So, since f is continuous at x equal to pi by 4, I can write limit x tends to pi by 4, f of x is equal to f of pi by 4. Limit x tends to pi by 4, f of x is equal to f of pi by 4. So then limit x tends to pi by 4, f of x. What is f of x? 1 minus tan x divided by pi by 4 minus x. This is equal to f of pi by 4, which is k. Well, now we have to evaluate this limit. Here if we directly apply the limit, we are going to get, directly applying the limit means putting x equal to pi by 4. When we put x equal to pi by 4 here, we get tan pi by 4. Tan pi by 4 is 1. 1 minus 1 will give you 0. Denominator pi by 4 minus pi by 4, that is also 0. 0 by 0, an indeterminate form. Okay. So then what else can we do? We cannot factorize like what we did in the previous problem. So here I will go for one substitution. That is, I will put pi by 4 minus x is equal to y. I am introducing a new variable. Let pi by 4 minus x, let it be equal to y. When pi by 4 minus x is equal to y, x can be written as pi by 4 minus y. Then as x tends to pi by 4, what will happen to y? Y will tend to what? When x approaches pi by 4, y will approach, yes students, what's your answer? Yes, 0, correct. As x approaches pi by 4, y will become 0. Okay. So whenever we make any substitution in limits, once we make a substitution, we have to change the limits also, because we are introducing a new variable here, y. Therefore, the next step when I write that limit should also be in terms of the new variable. So you have limit y tends to 0, 1 minus tan, in place of x, see pi by 4 minus x is equal to y, therefore x will be equal to pi by 4 minus y. Pi by 4 minus y. Denominator is pi by 4 minus x, which is equal to y. That's equal to k. Now if I apply the limit, still we are getting 0 by 0 only, because y is 0. If I substitute, I am getting tan pi by 4 here. Tan pi by 4 is 1. 1 minus 1 is 0. Denominator also 0. 0 by 0 and indeterminate form. Okay. So next, then what do? We know one formula. Tan pi by 4 minus y. Tan pi by 4 minus theta is equal to 1 minus tan theta divided by 1 plus tan theta. So tan pi by 4 minus y can be written as 1 minus tan y divided by 1 plus tan y whole divided by y equal to k. Right? Tan pi by 4 minus y can be written as 1 minus tan y divided by 1 plus tan y. Now limit y tends to 0. I will take LCM here. LCM is 1 plus tan y. Numerator will be 1 plus tan y minus of 1 minus tan y whole divided by y is equal to k. So here we have 1 plus tan y minus 1 plus tan y. 1 plus tan y minus 1 plus tan y. So 1 gets cancelled. Tan y plus tan y gives us 2 tan y. So here we have limit y tends to 0, 2 tan y divided by 1 plus tan y divided by y, where it will be y into 1 plus tan y is equal to k. Well, now as y tends to 0, what happens to tan y divided by y? As we know, limit theta tends to 0, tan theta by theta is equal to 1. So limit y tends to 0, tan y by y will become 1. So you have 2 into 1 divided by this 1 plus tan y. Y is approaching 0. So tan y means tan 0, which is equal to 0. That's equal to k. 2 into 1 is 2 divided by 1. 2 by 1 is equal to 2. Hence k is equal to 2. Okay, let's look at the next question. If f of x is equal to sin 5x divided by x square plus 2x when x is not equal to 0 and k plus 1 by 2 when x is equal to 0 is continuous at x equal to 0. Is continuous at x equal to 0, find k. So, very much similar to the earlier problems. If f of x is given by this function, defined like this. This is continuous at x equal to 0, then what is the value of k? Well, if it is continuous at x equal to 0, immediately I can write that limit x tends to 0 f of x is equal to f of 0. If f of x is continuous at x equal to 0, by definition we can say limit x tends to 0 f of x is equal to f of 0. So limit x tends to 0 f of x. F of x is sin 5x divided by x square plus 2x. That's equal to f of 0, which is k plus 1 by 2. First we will evaluate this limit. After that we will bring that 1 by 2 to LHS so that we will get the value of k. Okay, so how to evaluate this? If we directly apply the limit as x tends to 0, in the numerator we get sin 0, which is 0. In the denominator 0 plus 0, that is also 0. 0 by 0, an indeterminate form. Okay. So now, if you directly apply the limit, we are going to get indeterminate form 0 by 0. Here, I will take x as a common factor. So if I take x as a common factor, I am left with x into x plus 2. It is x square plus 2x. We can write as x into x plus 2. That's equal to k plus 1 by 2. So now, don't worry about this. We will just concentrate on this factor. We have sin 5x here and x in the denominator. So I am thinking about limit theta tends to 0 sin theta by theta. I want to use that formula. In order to use that formula, here we have sin 5x, but in the denominator there is only x. So what do we need? We need 5x here. So we should multiply and divide by 5. Okay? So I will write like this. Limit x tends to 0 sin 5x divided by 5x into x plus 2 into 5 is equal to k plus 1. See, I have multiplied by 5 or divided by 5 here, and therefore to compensate it I have multiplied by 5. Now as x tends to 0, sin 5x divided by 5x becomes 1 because limit theta tends to 0, sin theta by theta equal to 1. This 5 will remain as 5 only. This will become 0 plus 2, which is 2. So 5 by 2. The value of this limit is 5 by 2 is equal to k plus 1 by 2. Bring it this side. K is equal to 5 by 2 minus 1 by 2, which is 4 by 2. That's equal to 2. Okay? Now I'll take the last problem on continuity. F of x is equal to, if f of x is equal to 1 minus cos 4x, 1 minus cos 4x divided by 8x square, 1 minus cos 4x divided by 8x square when x not equal to 0, and k when x is equal to 0 is continuous at x equal to 0, then find k. Well, this function is continuous at x equal to 0, then what is the value of k? That is what they are asking. This is continuous at x equal to 0, so immediately I can write limit x tends to 0 f of x is equal to f of 0. Limit x tends to 0 f of x equal to f of 0. Limit x tends to 0 f of x. What is f of x? 1 minus cos 4x divided by 8x square. F of 0 is equal to k. Apply the limit here. Limit x tends to 0, 1 minus cos 4x. If I directly apply the limit as x tends to 0, we get cos 0 here. Cos 0 is 1. 1 minus 1 is 0. Denominator is also 0. 0 by 0, an indeterminate form. So, now I will use 1 minus cos theta formula. This is a well-known formula. 1 minus cos theta is equal to 2 sin square theta by 2. We have studied this in our first PUC. 1 minus cos theta is equal to 2 sin square theta by 2. So 1 minus cos 4x will be 2 sin square theta by 2. That means 4x by 2. 4x by 2. You can write 2x. Okay. So here 2 gets cancelled. So here in the denominator 4x square will remain. So we have limit x tends to 0 sin square 2x divided by, here I have cancelled this 2, therefore 4x square is remaining, that's equal to k. Limit x tends to 0, sine square 2x divided by 4x square is there now, I will write this as 2x whole square. 4x square can be written as 2x whole square. So here you have sine square 2x divided by 2x whole square. This can also be written as sine 2x by 2x whole square. As x approaches 0, sine 2x by 2x becomes 1. 1 square is 1. Therefore, the value of k is equal to 1. Okay, students? With this, we have come to the end of continuity. In our next class, we will discuss differentiability. Thank you.